Welcome back to the channel. If you ever wanted to see what rich San Juan Mountains gold ore really looks like up close, then you're going to enjoy this video. The faces of this sawn slice of rich gold vein are densely peppered with bright, metallic yellow gold, concentrated in bands and patches, like the ore is showing you the fluid pathways in real time. Stick with me, because this one is a classic Colorado high country gold story in a pocket-sized specimen you will not want to miss. And before we get into it, hit like, subscribe to High Country Gold and Silver, and ring that notification bell so you do not miss the next specimen. Today, we are in southwestern Colorado, up in the San Juan Mountains, at the Sunnyside Mine. This piece is labeled gold with sphalerite in quartz, and it contains the classic vein textures you would expect from this location. It is a sawn slab, cut to a really even thickness of about 0.8 of a centimeter, and it measures about 8.2 by 4.9 centimeters. The mass is 59 grams. And this piece is estimated to contain about 20 grams of gold, which is an eye-watering amount of precious metal for an ore slice you can easily hold in your hand. As we do the slow tour of the specimen later in this video, I want you to watch how the gold is distributed unevenly through the quartz and sphalerite, because that foreshadows the geology lesson. Let's get things going by switching over to the map and orienting ourselves to the location of the Sunnyside Mine in Colorado. We'll start out by zooming into the United States and onto the great state of Colorado. Then, we'll begin to focus our attention on southwestern Colorado and the San Juan Mountains. Moving in closer, we'll pause on the region roughly within Eureka to the north, Silverton to the south, and Telluride to the west. This region is known as the San Juan Triangle, and many storied mines, including the Sunnyside Mine, were located here. Moving in still closer, we arrive at the ghost town of Eureka, which was the jumping-off point to the Sunnyside and other mines within the namesake Eureka Mining District. Okay, now we're going to transition to 3D and focus on the high mountainous area directly up Eureka Gulch to the west of Eureka. This is the site of the Sunnyside Mine, on the shores of the extinct Lake Emma, above 12,000 feet elevation. You can really begin to appreciate the hardships these miners experience working in such rough and remote terrain. The Sunnyside even operated through each winter, when many feet of wind-whipped snow would blanket the mountainsides at this extreme elevation. Alright, now that we have a good sense of where today's specimen was originally freed from a rock face deep underground in the high country of Colorado, let's examine the mineralogy in more detail. Let us start with the big picture on the face. The main gang here is quartz, and it is the classic San Juan milky quartz. Bright white, dense, and massive, with a few slightly translucent zones where the cut passes through cleaner silica. Across that white quartz you have broad smoky grey to steel grey streaks and patches. Those darker areas are where the ore lives. The label calls out sphalerite, and the tone and distribution fit nicely with sphalerite-rich bands. Sphalerite can look dark grey to nearly black in massive form, especially when it is fine-grained and mixed with other sulfides. Now look at the metal. The gold shows up as abundant, irregular flecks and blebs, and it is not just one little spot. It is spread across multiple horizons, almost like the vein went through several pulses, and each pulse had its own metal load. In the lower half of the slab, there is a broad zone where the surface looks like it has been dusted with metallic yellow. Within that dusting, you get brighter clusters, where the gold grains thicken into little patches that catch the light all at once. That is the kind of flash you see when native gold is present as fine blebs, rather than a single nugget. In the middle of the piece, there is a diagonal transition, where the quartz shifts from clean white into more grey or rich material. And that is where the gold really organizes itself. You can see the gold following the darker bands and then spilling outward into the adjacent quartz as scattered grains. That pattern is important. It suggests the gold was depositing right along the reactive, sulfide-rich parts of the vein, and then a bit of it also plated out into the surrounding silica as conditions changed. Up near the top edge, there is another grey cap, and this one is loaded with bright flecks in clusters. It looks like a distinct band, almost like a later pulse that ran along the top of the cut. When you rotate the slab, the thickness makes it obvious. This is not just a surface stain. You are seeing a cross-section through a real ore chute, with the gold distributed through the vein material itself. Because the label specifically says sphalerite, I like reading the grey zones as sphalerite-rich ore bands. Sphalerite is the primary zinc sulfide, and in polymetallic vein systems, it is commonly paired with other sulfides like galena and pyrite. Some of the brassy sparkle in the slab could be other sulfides as well, but the standout buttery metallic yellow grains that jump out in those clusters are exactly what you want to see for native gold on a cut face. What makes this slab so educational is that it shows you how ore can be both banded and patchy at the same time. Hydrothermal veins are not one single event. They are repeated cracking, sealing, and re-cracking. Each time the fracture opens, fluid rushes in, pressure drops, temperature drops, chemistry shifts, and you get a new layer of quartz and a new load of sulfides and precious metals. That is why you see these sweeping grey bands, and that is why the gold seems to track those bands. You are looking at multiple generations of vein fill stacked together. Now let us place it back in the mountains. The Eureka District sits in the heart of the San Juan volcanic field, and the mining around Silverton is classic high-elevation underground mining, steep terrain, heavy winter conditions, and veins that cut volcanic rocks like tuffs, breccias, and flows. The Sunnyside Mine Group is one of the better-known names tied to that Silverton area vein mining, and it represents exactly what made the San Juans famous. Precious metals paired with base metal sulfides in strong, well-developed vein systems. In many of these San Juan camps, early miners were chasing rich gold and silver ore, and as development went deeper and along strike, the ore character could shift into more base metal rich zones with sphalerite, galena, and pyrite, while still carrying valuable gold and silver. That is one reason a label like gold with sphalerite in quartz is so believable in this district. you are in a system where zinc-rich sulfides and precious metals can ride together, especially in the stronger, more persistent veins. Geologically speaking, the best way to think about this is a polymetallic epithermal vein system, often described as intermediate sulfidation style. In plain language, that means hot, metal-bearing fluids moved through fractures in volcanic terrain at relatively shallow crustal levels. We are not talking about the deep roots of a giant porphyry copper system here. We are talking about a vein environment where fluids might be on the order of a couple hundred degrees Celsius, moving fast through fractures, flashing, boiling, and mixing with cooler groundwater. Those processes are exactly the triggers that drop metals out of solution. A pressure drop can cause boiling, which changes fluid chemistry and makes gold and sulfides precipitate. Cooling does the same. Mixing can do the same. And if the wall rock is reactive, it can force sulfides to form. The end result is what you see on this slab. Massive quartz as the main cement. Darker sulfide-rich bands that mark the most chemically active pulses. And native golds concentrated where the conditions were just right. The structure matters too. Veins like this are controlled by faults and fracture networks. When the same structure moves repeatedly, it keeps reopening pathways. That repeated movement creates banded textures, localized brecciation, and those sharp boundaries between cleaner quartz and ore-rich bands. On this slab, the way the gray zones cut and sweep across the quartz suggests multiple events, not one simple fill. That is the story written into the pattern. From a collector standpoint, this piece checks a lot of boxes. It has strong provenance with the Sunnyside Mine group in the Eureka District, which is a classic San Juan locality. It is a slab, which is perfect for studying ore distribution, and the thickness is uniform, so it displays beautifully and reads like a geologic cross-section. And most importantly, it has abundant visible gold, not just a single speck. The gold is distributed in a way that teaches you how ore chutes work. Zones, bands, and clusters that mark where the fluid chemistry and the fracture network lined up. If you collect Colorado gold, you know the range is huge. You can have delicate crystalline gold from pockets. You can have telluride ore from certain districts. And you can have this style of vein gold where the metal is intimately tied to quartz and sulfides. This specimen is a textbook example of that last category, and it does it with real visual impact. Alright, let's wrap it up with a quick summary. This is a gold with sphalerite in quartz or slab from the Sunnyside Mine group in the Eureka District of San Juan County, Colorado. A tight little window into how epithermal veins in the San Juan Mountains actually carried and deposited gold. You can see the pulses, you can see the sulfide bands, and you can see the native gold riding those pathways across the face. If you enjoyed this deep dive, smash that like button, subscribe to High Country Gold and Silver, and ring the notification bell. And drop a comment telling me what district, mine, or mineral you'd like to see featured next. Thanks for watching.